Hello team! We're going to go ahead and we're going to cover the topic of two-sided limits. Let's tackle this definition first, which can be intimidating. Then we'll tackle the problem with the pictures, and I think the definition will start to make a lot more sense. All right, let f be a function that is defined for all values of x close to x equals a, with the possible exception of itself, meaning that we could have a hole at the x approaching value. Then the limit as x approaches a of f of x equals L if and only if the limit as x approaches a from the right is equal to the limit as x approaches a from the left of f of x, and it's equal to that value of L. It sounds really confusing. Basically, it's saying this, and this is key right here. The two-sided limit exists if and only if the one-sided limits exist and are equal. Let's do an example with that. I've kind of hinted at this with tables in the homework before, so it shouldn't come as a huge surprise, but it's the first time we've really identified it. So first of all, I want to figure out what the limit as x approaches 2 from the right. It doesn't matter which direction we go in. Okay, well, we're approaching the x value of 2, and our function is coming from the right. Okay, here I go, I've approached 2. What is my y value here? It's 1. So that's my answer. Well, what about the limit as x approaches 2 from the left of f of x? Okay, well, let's approach it from the left. When I'm approaching it from the left, I get a y value of 2, and my limit is 2. It doesn't matter that that point doesn't exist there, no big deal. So the question is, with this limit, oops, sorry about that. The question is, I don't know what's going on. The question is, what is the actual limit as x approaches 2? So here's the real question. The limit as x approaches 2 of f of x is equal to what? Well, since these two values are not equal, our limit does not exist. DNE does not exist. So that's our first example. Now let's go ahead and let's try the next one. Let's try the limit as x approaches 2 from the right of this time g of x. See how we're at g of x there? And then I also want to know what's the limit as x approaches 2 from the left of g of x. Okay, well, as we're approaching from the right, you can see the arrows right here, my y value is 4. And as I'm approaching from the left, my y value is, again, 4. So the question that we really care about is our two-sided limit, right? We're looking at something from two sides. I want to know the limit as x approaches just plain old 2 of g of x, right? Of g of x. Well, our answer is 4, and that's because our one-sided limits are equal. All right, so looking back at our definition, it's saying that the right-sided limit is equal to the left-sided limit, and that value is L. Like in this case, it's 4. And so that would mean that our actual limit as we approach A, our two-sided limit, would just be 4 as well. So that's what it's saying. Okay, let's do a non-graphic example. Let g of x equal -1 if x is less than 0, and let g of x be equal to 1 if x is greater than or equal to 0. I'm actually going to tackle this problem without drawing the graph. I hope that doesn't freak you out. And then we'll graph it to make sure that we got the answer right. So let's do the limit as x approaches 0 from the left of g of x. And let's do the limit as x approaches 0 from the right. And it doesn't matter if you do the left or the right first, whatever one you prefer. Okay, if I'm approaching 0 from the left, am I going to be in the less than 0 category or the greater than or equal to 0 category? Well, if I'm approaching 0 from the left, I'm dealing with numbers like -0.0, 0, 1, or negative 0.05, negative 0.001. I'm to the left of 0. So that would definitely be the less than 0 category. So this is saying that you're always going to get negative 1 if you're a value less than 0 or to the left of 0. So our limit here is going to be negative 1. Well, what about from the right? Well, this would be a number like 0.1 or 0.05 or 0.2, something really close to 0 but not equal to 0. And so that would be this one right here. And so our limit is simply going to be 1. And this always works if you can plug that value into here. And there's no plugging in, it's just a number. Okay, now what can we say about the limit as x approaches 0 of g of x? Well, we've got an answer of 1 and an answer of negative 1. Do those two answers match? No, they do not. So the limit does not exist. Now, I do think it's worthy to actually graph this. And so if I graph negative 1, that would be the same thing as saying y equals negative 1. So that's a horizontal line at negative 1. I'm going to have an open circle, and that's because I have x is less than 0. But then if x is greater than equal to 0, then we have y equals 1, which is this. So it's pretty clear to see that there's no limit, because if we're looking at this function approaching from the left, okay, we clearly have a limit of negative 1. That's my y value there. And then if I'm watching my limit as I approach from the right, I'm approaching 1 for my y value. So here the limit does not exist. But the one-sided limits do exist. All right. I'm going to give you a problem, and what I'd like you to do is actually kind of pause and see if you can get the right answer. Let's try the limit as x approaches 1 of, we'll call this f of x. Go ahead and try that problem, and then try the limit as x approaches, we'll say 6, and you have seen this problem before. And in addition to telling me why there is an answer or there isn't an answer, I want you to tell me what the one-sided limits are. Okay, welcome back. So you should have had the limit as x approaches 1 from the left of f of x, and you should have had the limit as x approaches 1 from the right of f of x. Okay, well, from the left, we get an answer of 4 for our y value. And from the left, we're approaching up, and we get a y value of negative 2. Okay, so do negative 2 and 4 match? Absolutely not. The limit does not exist. I'll make it really clear when you have to explain to me using one-sided limits whether or not this function exists. Okay, for this next problem here, you can see that we are approaching the limit as x approaches 6. We'll go from the left. Okay, that's going to be from the left. We get a y value of 5. And if I approach 6 from the right, approaching it from the right here, I get a y value of 5 as well. So that would mean my limit is 5. Again, I would recommend kind of pausing this video and seeing if you can get the answers, and then I will go through it. All right, first one here, the limit as x approaches 3 from the left. That's going to be 3. Limit as x approaches 3 from the right. That is going to be, it looks like negative 2 from right here. So that means that this limit does not exist. However, it does want to know what f of 3 is. Well, that points right here. That's got a y value of 1. Right here, it looks like we've got the graph of g of t. And approaching 4 from the left, we have a limit of 5. That's this y value right here. And then approaching negative 4 from the right, it looks like we have this y value of 2. And then that means that our limit does not exist because our one-sided limits do not match. And g of negative 4 is going to be this point right here, which is 2. Or you can pause this again, or if you feel pretty comfortable, you can move forward with your lives. But I'm just going to get this extra example out. So here we go. From the left, we would be approaching here, and our y value would be 1, 2, 3, 4, -4. Remember, we're approaching 0 here. Approaching 0 from the right, looks like we get -4. That means since our one-side limits are the same, we have an answer of -4. What is f of 0? That's also -4. Very interesting. And what's kind of true about this function? Well, it's continuous, right? There's no holes. So kind of an interesting outcome for this particular problem. All right, next one here, the limit as x approaches -2 from the left. So -2 from the left gives us 3. As we approach -2 from the right, we get 3. So that's a limit of 3. What is p of -2? Well, it looks like it exists there. We get an answer of 3. So again, we've got a continuous function, and we've got all these values being exactly the same. Wonder if there's a pattern there. And of course, my favorite quote from any movie of all time will end with that: the limit does not exist. Please, please, please watch Mean Girls if you never have. It is a mathematical masterpiece. Thanks, everyone. Have a wonderful day.